Hey everybody. I was thinking about this the other day. What's our number of the day? Anyone have an idea what the number of the day should be? Do we count Wednesdays with number of the day? I don't even know. But if someone has an idea, certainly let me know. For today's little mini lesson, I just have one I guess addition to what we've done already with the last section. And then after that, I'm kind of done teaching, and we're just going to be looking at different examples, and we'll specifically review Power Series, and then we'll move on and do more of a review of everything as we get closer to uh, the AP test. So with that, I will switch over to this view. I want to take a look at three examples with you today. And the first one I'd like to take a look at is I would like to find a power series for y equals sine of x squared. And this is an idea. It has been a big part of AP tests in the past. I'm not sure how much it's going to be this year, but it's a nice little thing to be able to do regardless of whether it's on the AP test. It will be on my test one way or the other. The idea is this. We know what y equals sine of x looks like. Or maybe I should say we should know what it looks like by the time the test rolls around. We've seen the series. I listed it as one of those functions that we should know. But we know that sine of x is equal to, and I have to think for a moment about this one. Sine's an odd function, so I'm going to have odd powers. I'll have that alternating behavior that we'll see from sine and cosine. And sine must start with x. The first term's positive, so the next one must be negative. We're going up by odd powers, and at this point I do remember what it looks like. X to the 5th over 5 factorial, x to the 7th over 7 factorial, etc., etc. And if I wanted to write a general term for that, I could, but I think for today I'm just going to skip that, and let's come up with these series, and we'll take a look at general terms as they come up on example questions. So basically, I know what sine of x is. If I want to find what sine of x squared is, I can just replace the x with an x squared. I could replace the x with anything I want to, and that's whatever this stuff is over here. So if sine of x is this, sine of x squared, I'll replace this x with an x squared. I'll replace this x with an x squared, so x squared to the 3rd is x to the 6th. X squared to the 5th is x to the 10th. X squared to the 7th is x to the 14th. And at this point, I feel like I've established enough of a pattern to put the ellipses at the end and say, there we go. That's what the power series will look like for sine of x squared. I don't have my computer powered up. I guess we could plug this in Desmos and see what they look like, but it's going to converge pretty much like sine of x would have converged. So there's one quick example there. A similar example would be if I wanted to do something like y equals e to the square root of x minus 1. Well, same idea. We know what y equals e to the x looks like. Y equals e to the x is 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial plus x to the 4th over 4 factorial, etc. So if that's what, I should say that's what e to the x looks like. Well, then if I want y to the e to the x, e to the square root of x minus 1, I'm just replacing the x with the square root of x minus 1. And so this power series will look like, let's do this, y to the square root of x minus 1. There's no x in that term, so it's just 1 plus replacing the x with the square root of x minus 1. Replace that with the square root of x minus 1 squared over 2. Replace that x with the square root of x minus 1 to the 3rd over 3 factorial plus, I guess I'll write one more term down, square root of x minus 1 to the 4th over 4 factorial. And at this point I'm realizing, because I've got radicals in here, I suppose it's technically not a power series, but that's definitely the idea. Whether it's a power series or not, if I want to do something that looks similar enough to something that I know, I can do that. I can make the replacement. if I need to. And then the last example I want to take a look at in this video is a limit problem. We haven't done a lot of limit problems, but what if I want to do the limit as x goes to 0 of something like cosine of x minus 1 over x squared? And there's certainly a lot of ways that we could do this. L'Hopital jumps to mind as it wouldn't be a very difficult thing to do, but well, what can I say? In trying to come up with a creative way to do a problem like this one, this is what I came up with. So I would probably do L'Hopital also. But another way for us to approach this problem goes like this. We know what cosine of x looks like. Cosine of x is, here again, I'm remembering because I've studied diligently my functions to know. So I know that cosine of x is equal to 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, etc. And so when I look at that and I look at this, I think, well, I'm not doing just a simple substitution this time. I'm not just replacing x with something else, but I'm taking this, which is cosine, I'm subtracting 1 from it, and then dividing by an x squared. And the writers of the AP test like to do these types of problems where you've got some series representation of this, and maybe instead of a limit problem, maybe they want a series representation for something like this, which, well, let's get to that. Cosine of x minus 1, well, if this stuff over here is cosine of x, then if I take that and subtract away that first term, I'll be left with what I'm trying to find. So all I've done here is subtract away that x from the first term. By the way, if you guys have feedback for me on this, if watching me write this down is better than me having it prepared on a smartboard presentation, let me know. Or if you prefer this writing to me going through a slideshow, let me know. But I guess this is what I'm doing today. Anyway, this is cosine of x minus 1. I want cosine of x minus 1 over x squared. So let's do that. Cosine of x minus 1 over x squared is just going to be what I had so far divided by x squared. So I'll just take the power of each of these and reduce it by 2 because I'm dividing away an x squared. And I'm left with negative 1 over 2 factorial plus x to the 4th divided by x squared leaves me with x squared over 4 factorial. X to the 6th divided by x squared leaves me with x to the 4th over 6 factorial. If I need a few more terms of this, I could, but in the interest of this problem where I'm just trying to evaluate this limit, I'm just going to say if x is going to 0, that means all the rest of these terms, no matter how many of these x's show up down the road, these terms are all going to 0. So my answer for the limit as x goes to 0 of this stuff, cosine of x minus 1 over x squared, will be negative 1/2, because that's the only term that's left as x goes to 0. So there we go. That's the only other problem I wanted to do. So I don't really have an additional homework assignment. You should be continuing to work through the, I guess, 11.10 assignment if you haven't finished that one up. Also, by the way, if there are specific questions from there that you would like to see me work through, send me an email, put it on the Google Hangout, or let me know in some way that you would like to see. If there's any specific problems, I can add them to my video for tomorrow. Aside from that, I am going to post some PDFs of some free response questions, some the free response from AP tests in past years. I would like you to take a look at those problems, give them a try. Don't spend hours and hours, but I think most of my video tomorrow will be going through, maybe if I could get through 1 or 2 of those, I'd feel pretty good about that. So I think I'll probably post a few of them and maybe wait for any input from you guys. If there's 1 or 2 that you would specifically like to see, let me know that. And I think that's all I needed from you guys for this one. Test sometime next week. I'm not sure exactly what that's going to look like, but it'll probably be similar to what the actual AP test is going to be. I'll give you 45 minutes or 55 minutes or something like that, and I will say, here's some problems, write them out on notebook paper, and then take a picture and submit them, and then I'll grade them like a regular test. So there we go. Have a good night, and I'll see you virtually some other time. Bye.